ahead and introduce Steve. So Steve is going to be our presenter today. He's going to be talking about turn your data portal into a science gateway with Globus Compute. So the modern research data portal, MRDP design pattern, is used extensively in research environments to ensure security of an application while facilitating fast data transfer across a wide area network. We've adopted this design pattern to implement Science Gateway that enables data search, remote computation, and publication of resulting data products. So this is a great opportunity if you're interested in learning more about Globus. And with that, feel free to take it away, Steve.
Thanks, Claire. Let me share my screen. It would be helpful for everyone. Here we go. And okay. Yeah, as Claire said, I'm a professional services manager, Steve Sturoscy. I work for the University of Chicago for Globus. Also have a joint appointment with Argonne National Laboratory with their leadership computing facility. We do a lot of climate-related work for the Department of Energy. So I have an appointment with them as well. So both Chicago and Argonne. So what is Globus, real quick? Just if I'm unfamiliar with what Globus is, it is a nonprofit service. It's developed and operated by the University of Chicago with aid and funding coming from, as I said, things like the Department of Energy, from AWS, from Amazon, a decent amount of government-related facilities there. And then Globus has a subscription model that folks can pay for. And these are some of the institutions that are subscribed to Globus and aid in our funding. So Globus has lots of different platforms. And we're continuing to grow those platforms. And we're going to actually talk about a decent amount of those today as part of this modern research data portal and compute, because they're going to use a lot of these services sort of under the hood. So one of our flagship services is managed transfer and sync. This is using grid FTP in the background to manage large data transfers or even smaller data transfers, really any kind of data transfer. There should be more. There we go. So that this transfer and the idea of sync enables collaborative data sharing. You can create collections on your endpoints that you can share with other folks or other institutions. Unified data access. We have connections to almost any kind of storage that you have. So anywhere from POSIX to AWS connections to Google and so on and so forth. Publication discovery. This is where our search service comes in. So if you have data, then you can describe that data by metadata. You can publish that to our Globus search service. Manage remote execution. This is where we're talking about computing. And compute. Globus is building on what we used to call FunkX, and now is building on a model called Globus Compute. There's some announcements around that that I'll share with you a little bit later. Automation, so using these services together in a process called flows, and even programmatically, you can automate lots of different services. So you have software as a service as well. This is within our app. And all of those platforms as a service. They integrate Globus capabilities into your data portal, Science Gateway, Data Commons, or other research apps. So all of those platforms that I showed you in the previous slide can be integrated into lots of different things, on your end. Could be a CLI tool, a data portal tool, or just simple scripts running somewhere. So here's what we're going to talk about today. We're going to talk about flows, and I'm going to show you some examples of flows. We're going to talk about compute. Think of a remote compute endpoint resource. We're going to talk a little bit about search via science portals and a little bit about authentication with all of that. So Globus flows. What are Globus flows? They're managed secure. It's basically task orchestration. So a flow you can chain events together as step functions. So the heterogeneous resources, so you can use all kinds of different resources within a flow. There's an event-driven execution model. You can create custom actions on top of the Globus provided actions. So it's very extensible in the sense that if you're comfortable with getting into a little more customizing, you can do that with Globus flows. Globus flows service. You can sort of see the image on the bottom part of your screen there. Sort of gives a good idea, and this is just a sort of arbitrary flow that was sort of linked together in an image, but basically you can do any number of those things within a Globus flow. Wherever you see funcex, imagine it says compute. Funcex, that's a relic of an old thing that some of our slides need to be updated, but that's the funcex is actually our compute service. So this particular flow describes auth and transfer, some compute functions running and maybe transferring the results of that compute somewhere else. A user input web form, which kicks off another compute resource. And then that ingests into a search index somewhere, which gets identified and then shared and able to be searched. And all of those things, if you look above, are called actions, and there are subsequent action providers. So the action providers are called by flows to perform these tasks. Triggers, we are working on triggers, but you can think of a trigger as a new file gets dropped in a file system somewhere, and that file needs to go through a certain number of steps, ultimately getting ingested into a search index, like say, according to this diagram. That would be a trigger. And you see a lot of that happening from instrumentation. So an instrument does something, it produces results which need to go somewhere. And once those results are available, then a Globus flow can come in and do things with it. Let's keep going here. They're built on, a lot of our services are built on AWS. This one is as well. That's built on AWS step functions. So if you're familiar with step functions, it works very much the same way with a Globus sort of layer in there in between. So it's simple state machine language, mostly logical conditionings and loops, and then the propagate state through the flow. So you can do something with something in one part of the flow, and you can propagate that to the next so that it realizes what each state is doing. Standardized API for integrating custom event and action services. We talked about that already. You can create your own events on top of what Globus provides. And then on top of that, they are secured with Globus auth. Creating and deploying flows. I'm going to show you a little bit of this in a second, but they're generally deployed and defined using a very declarative and common language in JSON or YAML. Very clearly defined, and in our documentation, pretty clearly defined. Globus flows to the Globus flows. You deploy to the Globus flows service. Then you can set access policies for who can actually see the flow down to who can and run it. And then you just see kind of another sort of flow diagram there with a simple one where you just have action, 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 one where there's a choice, you can kind of branch off and go into different actions. Right now, there's two, I would call official Globus provided flows. I'm going to show you those in a second. So I'm going to move past this slide pretty quickly, but this is just a quick snapshot of our web interface. And you can see all of these flows. You can even deploy flows within the web interface. And you can run flows within the web interface. You see that start button right there. That you click on that, and that is going to actually show you an interface defined, or actually based off of your input file, what that's going to look like in the Globus web app. And like I said, I'll show you that in a second. We can search and discover available flows. I think that might be running Globus flows. So there's any number of ways to run Globus flows. I'm going to show you three different ways. One is start and manage the runs via the web app or the API. So we have an API and we have a Globus SDK. You can use either of those to manage flows and runs related to flows. You can use a CLI. I've referenced the SDK already. The CLI can do a lot of Globus related things. So the CLI is pretty powerful. If you're comfortable with a command line tool, I would urge you to take a look at Globus's CLI. Event-driven execution, this is where the triggers came in, where a drop of a file might, or new data available off an instrument might trigger a flow, or in our case, from a science portal. Managing flow execution, again, we're going to see this. You basically provide inputs and run the instance of the flow. You can check and run, you can check the run progress. You can cancel a run if you need to, if it's a long flow and for some reason you know it's going to error at some point, you can cancel the flow. And it's been stated a couple of times where you can set access policies for monitoring and managing all of these things. I will show you that. And I think, yeah. So let me exit out of this. I'll pause for a second. Are there any questions so far?
We don't have any questions in the chat at the moment, but if anybody does have a question, feel free to put it in the Zoom chat.
Okay. So hopefully everybody can still see my screen here. What I'm showing you here is the Globus web app. It defaults to our file manager, which is basically just searching collections that I have access to with data and being able to transfer results to and from. What we're going to look at here is the flows tab. And I want to look at the library and click on Globus provided flows. So right now you see we have two here. If I click on this two-stage Globus transfer, you're going to see the name, subtitle, and description. Who owns the actual flow? The data provider is Globus off. And it says it's 25 steps here. It is not. It isn't 25 steps. It's more like 4 or 5. I'm not sure why this steps has been padded out, but you'll see the actual steps involved here. If I look at the definition, as I said, this is basically just YAML or JSON. Each has a state that is defined by an action URL. And these can be custom or the actions can be provided by Globus. So then we also have, let me click back here, an input schema, which defines your inputs for each one of those stages. So if I go back to overview and I click start, this is what the input file is going to give us. I'm going to click a tab ahead over here because I have one already sort of filled out. This is the same flow. I just have files chosen. All you would need to do here is provide a source, an intermediate, and destination. All this flow is doing is taking a file provided by the source, sending it to an intermediate destination, and then sending it to its ultimate destination. Simple, pretty simple flow. So if we run this, label the run, let's call it tutorial SGX. Start the run. Hopefully it'll. So now we see a couple of different things here. We want to review the run details, and we want to see the event log. So we can see here each stage. We can see the reason this is more stages because it's has a few intermediate steps here. So if we click on view details, we can see each one of these. Succeeded, details about the data, so on and so forth. If it were to fail, you would see information about why it may have failed. So basically what we did here, I don't even necessarily need to show you the end result of this. There should be, in the intermediate destination here, let's see if it's there. There should be a .nc file in Globus search tutorial 1. If it's not there, it hasn't finished yet, but it's not necessarily something we necessarily need to, there we go. We can even come back to it later. Let's come back to this because the flow actually hasn't even completed yet. I want to show you a different way to kick off a flow. This is our Jupyter lab demo. So you should be able to access this through this URL here. This is basically has a few different canned resources for Globus things. So automation, compute, we're going to look at that a little bit later, data distribution, so on and so forth. The one we're looking at right now is automation using flows. And basically, this is just a programmatic way to kick off a flow using our SDK. I'm not going to necessarily go through all of this or run these because, in interest of time, I want to make sure we kind of keep moving here because we still have compute to talk about and we still have the actual research data portal stuff to talk about and any questions that might come up along the way. But basically, what this is doing is it is defining a few variables here: a source destination collection and collaborators. This is a group ARN, a group identification here that's going to be used to set some access policies on whatever is transferred. The client ID, this is used to register with Globus Auth. I showed you this. Globus Auth is in settings and developers. Once you get there, this is where you would register a service account or a portal, things with client IDs and client secrets. So that was registered via that website and then transferred over here. Authentication, authorization. We get scopes. We do a native login. This is going to exchange a code for token. And once you exchange that code and paste it in here, you would get your tokens, and then you would actually get your flow authorizer and a flows client. So here's where the actual flows client is instantiated from the authorizer. We need some additional scopes here. So we need to fetch a couple more identities. This is related to Globus Search Index. And here's where the meat of this actual Jupyter demo is this flow deployment. We're defining that flow definition that I showed you within this definition here. So it's very similar to that. And then we define a schema. This is the input schema that I showed you before. And then from there, we create the flow, and then we actually run the flow. So you should have access to these Jupyter demos. If you don't, let me know. So that's kind of, I went fast through this. This is just another way to kick off a flow aside from the Globus web app. And when we get to the end of this tutorial, I'm going to show you a third way through the web app. Essentially, it's just through the Globus SDK again, but it's used the Globus portal framework is using that under the hood. Again, I'll pause another time here for any questions. I don't see anything in the chat, but
We did just have one question regarding the being able to share the URL that you have in chat.
I'm hoping this works for everyone. If it doesn't, then we'll figure out how to get access.
Great. And then there was one other question that I received about access to slides after the meeting.
I can provide wherever slides need to end up. I can provide those if there's an easy way to do that. But yes, I'm happy to provide slides. I could probably even do that through Globus Google Drive.
Sounds great.
Yeah. Okay. Let me see here. Let's go back. So that kind of sort of ends, not really ends, but that's the quick of what our flows service is. It's AWS step function based service that can run other Globus services, based on certain conditions within your definition and input files. All right, let's go back to. So now we're going to talk a little bit about compute and what that looks like and how we might incorporate compute into a Globus flow. What is compute? It is what we used to call FuncX. It's managed federated functions as a service. So you can kind of think Lambda, I guess, AWS in a way. But wherever you have Globus compute installed and you have an endpoint designated, you can run any function through that endpoint as part of this service. They're reliable, they're very scalable, kind of like Lambda. They're very secure for executing functions on remote endpoints from laptops to supercomputers. So if there's time, I think there will be. I'm going to show you an endpoint on my laptop that will run as part of a Jupyter Lab demo. What are the makeup? What are the Globus compute elements? So there's a Globus compute service. It's a highly available cloud-hosted service, provides managed fire and forget function execution. So that's the sort of overall service that's running under cloud-hosted services by Globus. What is a compute endpoint? Abstract access to the compute resources. So this is where you would use Globus, the Globus compute endpoint tooling to set up your own endpoint on it could be a supercomputer, Polaris at Argonne, or it could be your laptop, like I have here sitting in front of me that I have a Globus compute endpoint on as well. You have an SDK, so there's a Python interface for interacting with these services. Very familiar with Globus look and feel. And then there's a level of security in there which leverages Globus auth. Compute endpoints are resource servers, auth and access via token. So you have that layer of authorization in there with Globus. Again, ignore wherever you see funcx, can imagine compute. So making a system accessible to Globus compute. It's pip installable. It's a single user endpoint now. So one of the things I'm going to show you later, but I'll have good news as part of the bad news in the demo. Right now, the Globus compute endpoints that you install can only be executed by a single user. The multi-user Globus compute was announced at Globus World. It is coming. It's still, I don't think quite ready for release. I don't want to say too much because I don't know all of the ins and outs, but I do. It is announced. It is coming, and it is something that you will be able to do in the near future. Parallel execution, local fork, or via common scheduler. So you can execute these functions as part of Slurm, Cobalt, Kubernetes, those kinds of things. Let's see here. Executing functions. Users invoke functions as tasks, register Python function body. You can pass input arguments to the function, and you run them on select endpoints. Globus stores these tasks in the cloud, and then the endpoints, they fetch the waiting tasks, run the task, or return the results or errors. Users retrieve the results through the SDK, and then do whatever is needed with those results. Okay, so again, I'm going to pause here, and I'm going to jump over to the compute. Okay. So this compute Jupyter Hub is similar to the one for transfer, and that it's going to import all of the necessary modules that we need in order to run this particular Jupyter notebook. So notice that all of these come from, or not all of these, some of them come from the Globus Compute SDK. Again, that is pip installable. Documentation for Globus related services are actually quite good. So each of these services comes with lots of different types of documentation, from strict API documentation to SDK to CLI to examples like this on Jupyter. So we're importing our necessary modules. So you might be questioning yourself or asking the question, if compute endpoints are single user, how can we have a tutorial endpoint that anybody can execute functions on? The answer is that this is a special endpoint. Right now, this is endpoint acts as a sort of endpoint that if you're in a particular Globus group, you can run your functions on this endpoint. I believe this is sort of something we're reaching for multi-user. So you can run this if you want. There's a lot of code to actually get the executor, which is right here. And then actually submitting the function, which is just returning a hello world. And then we're actually getting the results of that by saying future.result. So the neat thing is here, this is a public tutorial endpoint. So this, if I go through all of these steps, which shouldn't take long, here, let's do all the auth. So we have the actual executor here, then we're going to run this. So we have our future return. We'll see if that's done. It should say true. And again, this should just repeat hello world. Yep. So if I go back here to my command line and I have the CLI installed for Globus compute endpoint, and I list the endpoints, a default endpoint will get created by calling configure. So I can call that again, and I could say configure a tutorial endpoint. So if I list, I see my tutorial endpoint, but it's still initialized. It hasn't started yet. So we want to say, so now that function's been registered by the Globus compute service. And if I list again, now we see that it's running and we have an ID. So I should be able to say, I should be able to copy this. And take this. And it should be able to run on my laptop. So let's update this. I don't think we need to update this, but we'll run it again. This may be giving me a warning. Nope. Oh, yeah. So it looks scary, but it's just a mismatch between versions. It should still work. Done. And hello world. So what I did there is I ran the same hello world function on a tutorial endpoint. I forget it's installed on Argonne resources. And then I ran the same function on an endpoint on my laptop. So you can see that one end of things, laptop to supercomputer. The supercomputer requires obviously more configuration. But if you have access to run these things on supercomputers, you can install the Globus compute endpoint and run them there. I think, the other way of doing this is through the portal framework and through flows, which actually kind of brings me into the next and final part of the presentation. But again, I will pause. Any more questions? I'm not seeing anything in chat for everyone. If there isn't, I can move on. Okay. Do all the services require subscription? No. Not all the services require subscription. There are portions of each service that are available for free. And then mostly things related to access control is when you start looking into subscriptions. For example, Globus Transfers is free, but if you want to start to creating things that are called guest collections are basically a mapped collection, but for sharing. So a map collection you can only access yourself. A guest collection, you can set policies on it that you can have whoever you want to access it. That right there as a part of the subscription service. Okay. Okay, so we talked about triggering flows. We talked about compute. So we're going to trigger a flow and in turn trigger a compute function from within that flow. So before we do any of that, I wanted to talk a little bit about the MRDP, the Modern Research Data Portal design pattern. This is well defined. This is well researched. You can read more about it at that URL right there. Basically, it's just defining what a portal should look like and what resources it should contain in order to call itself a modern research data portal. I think Globus fits a lot of those services within the portal, and you'll kind of see that as we go here with what our definition of what a portal framework should look like. We talk a little bit when we talk about these frameworks. You need to talk about how your overall architecture is sort of set up. People have probably seen these slides before. I think I presented them last year at SGX face to face. But essentially, what this legacy architecture is doing is you have a file system store with direct access to the Science Gateway server. So your gateway logic is running through everything, which is small, but then you're wanting to do things with the file system, presumably, upload, download, or transfer. And those, for all intents and purposes, could be large data transfers. So you're mixing those sort of the gateway logic and research data, and you can create some bottlenecks there, in that path. If we look at a best practice, which we call a science DMZ, your file system store is only accessible by your data access nodes. So your DTNs here, which is, I should say, data transfer nodes, these are where Globus are installed. And this is an endpoint with a collection to your file system data store. So we're doing transfers across these DTNs through your router, and then your Science Gateway lives over here on a web server with Globus Search enabled, running in Globus Cloud, maybe a database running with Globus authentication. So you have this firewall only dealing with these easy, more or less HTTP requests, and then your DMZ with your DTNs is where Globus sits, dealing with your file system store. Does it need to be customized for specific research needs or data sets? It typically does. So you can take our Globus portal framework, which I'll show you in a minute, but it'll work out of the box for what it's set up for, and that's an example search index. If you wanted to incorporate your own search and transfer, there is some customization you would have to do. It is being recorded. Okay. Sorry, I was pausing to see if there's anything else in chat. So it says down here, only gateway logic, small data traverses the enterprise firewall. Fast, clean path to research data. Typically, you're doing your search here, and I'm going to show examples of this. You're doing your search, and then your search has pointers to where the data lies, and then your gateway server would open the Globus web app to whatever data you're trying to transfer. Typically, the way it's done. So the key elements for the modern research data portal design is a Science DMZ, which is a fast, clean data path. You have your purpose-built data transfer nodes, which are moving, actually using Globus to move the data. Globus Connect installed at the DTNs, which is the storage system enabler. You have the Globus platform running with the Globus portal framework for data discovery and access. The platform here would be data orchestration, would be search, transfer, whatever other Globus services you're using there. Okay, so Science Gateway reference implementation. We talked. This is that bottom sort of three boxes there. The Globus platform, within the portal framework, provides Globus auth, so federated authentication. I think we had I heard it was like 15 or 1600 different IDPs that you could authenticate with. Globus search, which is metadata management and faceted search. And again, I'll show you an example of that. Excuse me. Globus transfer, reliable data movement and sharing. And then on the other end, you have Globus flows and Globus compute. And we can sort of tie a lot of these resources together, a lot of these services together. Okay. So the links on the bottom are for what I am talking about on this slide. So we have a predefined Globus portal framework, which is built on top of Django, which is built with Python. I'm hoping most people are at least familiar with Django. It's a very widely used framework, really to almost do anything web related. Build APIs, build web apps, web services, lots of different things. So we chose Django because it is so extensible and it's pretty widely used as the framework for what we define the Globus portal framework to be. So the question was before, does the Science Gateway need to be customized? If you wanted to spin your own framework up, your own portal, using Globus services, this would be where you would start, and you would look at the docs in order to integrate your own resources in there. So what can we do with this? We can use Globus auth for federated login, as I said before. We can export data via Globus transfer. There's a number of ways of doing that. We can browse data sets with Globus search. So we can search and find data sets that we are of particular interest to us as a researcher. And then we can say, I want all of these data sets. I want them transferred to my laptop, or I want them transferred to some storage attached to a supercomputer somewhere that needs to analyze them. So we can do that. Template-driven search results. This is where the actual Django framework comes in and makes it easier to update. Extensible templates. And we have something called the Django Globus portal cookie cutter, which is basically an easy way to bootstrap an application. There's a lot of stuff on this slide, so I'll pause for a second or two to see if there's questions here. Okay. So portal framework and compute. So I talked about flows. We talked about compute. We talked about the MRDP and portal framework. We're adding all of these things, and we're sort of making a mashup of all of these services. So we're using a portal framework to search results, and then we're using the Globus SDK to kick off a flow, which kicks off compute services. So discover, select data of interest, run analysis on that selected data via Globus compute, run on any resource, move, optionally share the analysis results, and do this all reliably at scale with Globus flows. So all of the services being used together. So our demonstration, let me click. Let's see here. Okay. So our environment, ALCF at Eagle, we have a compute resource and we have an instrument with data coming off an instrument onto an EC2 instance with a compute resource is also running on EC2. Or you could consider it, a Polaris is a supercomputer that we have at ALCF. It could be running on there too. Data endpoints. So we have a data endpoint at the instrument. We need to transfer that to another data endpoint, which is our compute resource, which does some analysis on it, which then sends it to our massive storage facility at ALCF called Eagle. So two separate transfers there. So we have a monitor script, presumably when a new data set is available. We have a registered function on the compute resource, compute endpoint, where that function lives. A trigger, new data sets available, monitor script triggers a flow run. We transfer files to the data endpoints. At that point, Globus is in the background taking control of the transfer. So those are all Globus services doing this. Installed on GCS. The data endpoint is grabbing this data point is grabbing those resources, those data sets, and running compute. So it invokes that image processing function. It transfers the results of that compute to the data endpoint at ALCF, which is Eagle. I think that's the end of the diagram. No. Oh, and then we're setting permissions on those data sets, on that data at Eagle, and then access the result files. That's it. Okay. So again, I'll give you a second to sort of look at. There's a lot of arrows going all over the place. In a nutshell, that's what this flow is doing. Questions on this? Okay. So I'm gonna show you this live as well. There's a bit of bad news with it, and I'll share that with you when I get there. But this is an example of our kind of a typical example of what our portal framework looks like. This is for FEMA related data, I believe. Basically, this is just in a sample data portal that's set up that can kick off flows and also kick off compute. This just shows a little bit of the interface. You have the faceted results on the left-hand side, so you could define whatever facets you want to call out in your settings file. It's all settings based. So you define your Globus search index, which you've ingested metadata into, and then you have any keys in there that you can set faceted search on the left-hand side. So easy clickable checkboxes for quick search. You can do more targeted search with the input here. With basically query params on your metadata. So these are these are what we would call data sets. This is your each data set here essentially is a JPEG image. We're going to see this in the live. This is we can analyze the data using Globus Compute. So we've narrowed down a particular image file we want to analyze, and we can run compute on that. And then we can manage the flow run, and we can analyze the results when it completes. So here it is, again, sort of in a nutshell, Globus flow for data analysis. Transfer selected file to compute, run compute, process the selected data, move those process images to a repository, set access control rights, make them available for further search. Okay, I'm going to come back to that. So just to give you an idea, before I get to this one, this is what we were looking at before. And I wanted to show you this. This is for a project that I'm actively working on now with Argonne, Oak Ridge, and Lawrence Livermore National Laboratories for climate data. Currently at ALCF at Argonne on Eagle, I think there's 8 petabytes of data that is searchable. That's been defined by metadata and can be searched through this interface and other interfaces. So if I uncheck CMIP here, there's roughly 5.4 million data sets. There's more at other locations, but this is what we have at Argonne right now. If I click on, let's narrow that down a little bit, maybe even more. So you'll see a transfer data sets here because I am logged in as UChicago. If I click on this, it's going to tell me that I have 516 files of 765 gig. So then I can choose destination paths. If I want to choose a different location, it's actually going to bring up Globus helper pages. I'm not going to actually do the transfer. But if I were to click here, that would go to the tutorials endpoint that I just chose. So that's kind of the transfer portion of this in a nutshell. If I look at a data set, we have files in the data set. There could be one or there could be many. I can transfer this using Globus with the same sort of helper pages as before. Or if I know this is rather small, I can click on download via HTTPS, and it's going to start to download that there. Or I could click on transfer sync, which will give me the helper pages, and there's that file. So that's transfer search within the Django Globus portal framework. I'll pause again for questions. Okay. Okay. So we can do relatively the same thing here. This is using the same. So you can see like some commonality here, between portal frameworks and how Globus does things. This is what I would envision anybody who wants to use a Globus a portal framework would, and wanted to use the helper pages would look very similar to this. Let's search older images. So this midway is another computer running at Argonne. This endpoint is down, so I know this will not work. This will work to a degree. It's going to fail. I'll tell you why, and you'll probably see why. So let's run this pipeline. This is going to run the pipeline on EC2. So essentially, it's doing those steps that I showed in the slide. So we can manage the flow run. I go to the event log. So this action failed. If anybody in chat can guess why this might have failed. I mean, I know why. But I said there was a caveat before, for now, to compute. I did not set up the compute endpoint. It was set up by somebody else. So I, as Sturoscy at uchicago.edu, do not have access to run that. So where this would get fixed in the very near future is access policies for me to run this. There are some workarounds. For now, you can use client credentials, a client ID and secret. So if you do want to run a compute endpoint that's a little bit more public, you could manage it that way. You could create a client with the SDK with those credentials and run the compute endpoint. But that is why this is failing right now. So what's failing to do is actually process the images and then send them to Eagle or send them somewhere to the endpoint. But what you would see is just an analysis of that image, and that analysis is a very exciting thumbnail image of a larger image. That's all it's doing. But I'd like to update this flow, and I'd like to update this overall presentation when multi-user is available to use that. Otherwise, we're going to run into this issue with other people running these endpoints. So I'm trying to think if I have anything else. Let me go back to my presentation. Yeah, so that's what that process did. Where it failed was this compute to actually then transfer and then share the results. So what resources? Documentation, docs.globus.org. YouTube channel. We update that fairly regularly with things that we do. So if you're more visual, I would check that the YouTube channel out. Our help desk is amazing. They are extremely prompt and very detail oriented. So if you want to get in touch with our help desk, support at Globus is recommended. We have mailing lists. Actually, I haven't been on the mailing list in a while, but if you want to check those mailing lists out, go to that URL. We have office hours for our customer engagement team and our professional services team, which I am on. We're brought on an advisory basis for more custom type work. And a lot of that work is related to university and government facility, Department of Energy type stuff. So that's what I have for today. There's 6 minutes. I kind of intended to give 5 to 10 for any questions, but it seemed like they were kind of being asked along the way. I'm happy to stop here and answer any questions.
Thank you very much, Steve. This is great.
No problem.
For folks that have any questions, feel free to raise your hand. No, Mona just shared comment. Very impressive and nice to see many services have been added in the last few years. So kudos there to Globus. Drew does have a question. Do you custom consultation for projects planning on using Globus? So do you provide any custom consultation?
Yes, we do, depending on the project, and that is the decisions for project management in that sense are one above me. So how projects get spun up is actually through the professional services team, but through there's 2 individuals, Vass and Rachana, would decide upon that work. But we typically do. I would probably advise you to maybe send a quick message to support at Globus with a definition or a small idea of what you're thinking. And I think depending on what would be decided next, there would be some meetings. Yeah. Yeah.
Great.
Yeah. Thanks, Claire.
Yeah, you're welcome. Any other questions from attendees we could ask Steve?
I will figure out how to share these slides with folks, and stay tuned for the next, over the next day or two. I'll share them out.
Sounds great.
Yeah. And I don't know if I'll be at SGX face to face. I do know Globus will be there. So if I know that's not until October, but if you want to come over and say hi to us, we'll have some presence there.
Absolutely. Yeah, we'll definitely have
Thanks,
Globus at Gateways 2024. They're going to be a sponsor for us this year again. So looking forward to that presentation and opportunities to be engaged that way.
Great.
All right. Well, with that, we can wrap up a few minutes early if we don't have any additional questions. We will post the recording on our YouTube channel afterwards. And we'll do a short survey as well to those that have attended. So if you have any feedback on how well the webinar went, any suggestions for future webinars, we would love to get that feedback from you all. But with that, let's thank Steve one more time. Thank you, Steve. Greatly appreciate it, and we'll talk to everyone soon.
You're welcome, and thank you. Appreciate it.
Thanks, Stephen.